speaker, Jim Steele. He's coming to us live from the Gold Coast of Australia. Dr. Jim Steele from CSIRO is a senior software engineer, and he leads the health data and FHIR team there with the Australian eHealth Research Center. He's a lead developer on Onto Server, which is a FHIR terminology service that is at the core of Australia's National Clinical Terminology Service. It is used across government, public health networks, and also by clinical software vendors. He brings over 2 decades of experience as a researcher, lecturer, and engineer in software modeling across a range of fields, including but not limited to enterprise systems, architecture, constructions, and e-health. So we're happy to have him with us this afternoon. And then our moderator will be Pavel Smirnov with Health Samurai. He is CEO of Health Samurai and is a well-known FHIR trailblazer. So with that, we are going to turn it over to Jim Steele, and he will take it from here.
Thank you very much. So I'll start by sharing my screen. I was introduced as being on the Gold Coast. Unfortunately, I'm up at Brisbane. I'm not at the beach today, but hopefully I'll get down to the Gold Coast perhaps this weekend. So today I'm here to talk about FHIR Terminology Services. I suppose a bit of my credentials, Pat has already presented some of them. So I work for CSIRO. We're Australia's national research agency, working across all kinds of science, including e-health. And we've been working on clinical terminology, particularly for about 15 years now, including about 5 years distributing Onto Server, which is used widely in Australia and the UK and Europe and a few other places to support all sorts of use cases, a lot of which I'm going to talk about today. So FHIR Terminology Services. So why is terminology interesting when we're using FHIR? As much as structure definitions are the cool structure of FHIR, it really is the terminology that's the muscles of that. When you receive a resource, a FHIR resource, the structure definition will tell you what the elements are, but the real meaning of what makes a condition diabetes or what makes a procedure a laparoscopy or whatever is going to be in the coded data that lives inside those resources. So it's a really important part of the meaning when we're sharing FHIR resources. It's also a very important part of defining profiles, because knowing about terminology and particularly about value sets, which we're going to talk about, is a very important part of defining profiles where you want to narrow down or perhaps even broaden out the different codes that can appear in your FHIR resources. Terminology services is really useful because in a large integrated system, it gives us a way to have a single reference for terminology, which is really useful for interoperability. And even more important than that, it's a single way of asking questions about terminology. It gives us a way as well to have externalized terminology services. So you can factor out the terminology aspects of your system to a dedicated server, whether that's a dedicated terminology server or just a dedicated FHIR server that handles terminology for you, which gives you that sort of centralized point so that if you're bringing in a new version of a coding system, then there's a single place you can go to query that. So in terms of when we're doing things in FHIR, some of the use cases that we're going to talk about today that use terminology, data entry is one of those. So when the clinician or an administrator or a patient is trying to enter data into a system that's using FHIR, they need to be able to quickly find the right code to record the data that they're recording in a specific context. In a validation context, if you're receiving data, FHIR data, then you often need to ask questions about whether the codes you're receiving are valid for the contexts that they're being presented in. For display and understanding, so when you first come to see a set of codes, you need to sort of ask questions about those codes to try and understand what they mean. Terminology is really important for mapping, which I'm not going to go into a lot of detail today. But
Jim, excuse me. A lot of questions about slides. Do you have slides or there is no slides?
Yeah, sorry, they're not visible yet. I will actually share them. How's that? Is that showing the slides?
We're seeing a blank white screen, Jim.
Ah, that's the wrong one there. Sorry about that. How are we doing now? Is that better?
Yep.
Okay, thanks very much. So mapping is another really important place where terminology is used. So you'll often receive codes that might be proprietary codes, or they're expressed in some coding system that you don't understand, and you need to be able to map those across to some normalized code system that you want to deal with. If you're doing analytics on FHIR data, then terminology is a really powerful way to be able to break that data up into categories and to be able to just sort of show breakdowns of the data so that you can really start to get some understanding of it. And then we very often need to author our own terminology resources, particularly code systems and value sets and concept maps, whether we're doing profiling or whether we're doing system integration or different sorts of things. And then there's a final use case down the bottom there. Hopefully that shows up. Is if you're building a FHIR server or some server that's storing clinical data, then integrating with a terminology server can give you a lot of power in terms of supporting particularly smart search of the data in your repository. So when we're looking at FHIR, there's a bunch of places where we see codes. And when we see terminology, and there are 3 data types in particular that are interesting. Code is just a code. So you'll see this in resources where the coding system has been fixed by the FHIR spec. So things like administrative gender on patient, for example. And when we see this data type, we don't need to provide a coding system. We just provide the code because the coding system is understood because of the context we're using it in. You'll sometimes, less commonly these days, you'll see the coding data type. Coding, the most important parts of that are you provide a system and a code. And then optionally, you can also provide the version of the code system that was used, the display text that the user saw, and whether the user explicitly selected it or whether perhaps it's a code that might have been mapped from what the user selected. And then probably the most common place where you'll see terminology in the FHIR spec is codable concept data types. So this allows you to have a bunch of codings. So there might be alternate or mapped codings, for example. And you can also have a text element. So I'll show a couple of examples of these in a second. And the 4th place where you'll see terminology in the FHIR spec is in search parameters. So you'll often see search parameters that are token typed when you're dealing with coded data. So that allows you to search by providing both a system and a code, just a code where you don't care which system, just a code where you know there's no system, which is a rare case. And you can even search to say questions like, show me a condition where there's any SNOMED code put on it by just saying you care about the system. And then where it really starts to get interesting is that there are some modifiers that you can put on those search parameters. And particularly interesting are the below and above modifiers, which allow you to query the hierarchy in the terminology. So you can say, not just show me any condition where the code is diabetes, but you can say, show me any condition where the code is diabetes or any of its descendants in the code system hierarchy. And the other really interesting one is the in modifier. So this allows you to provide a value set URL to say things like, show me any condition where the code is in this value set of chronic diseases or whatever value set you've constructed. So you can start doing really rich search like that. So this is just a quick example of where these coded elements appear in a FHIR resource. So this is a fairly simple encounter resource. And there are 3 different examples here of the coding, the terminology related data types. So the status resource here just says in progress. That's a code. That comes from a code system that's defined for that status element. And it's a fixed system. It will always be this code system for that element. So we don't state the code system at all. The class element on the encounter has a system and a code. So this is a coding typed element. So it allows us to specify both the system and the code. We could also have selected version and user selected and display text if we'd wanted to. And then the 3rd example here is the reason code element. And this is a codable concept. So we can have multiple codings specified. So in this case, it's specified a SNOMED CT code, and it's able to tell us that this is the one that the user selected. And it's It's also giving us the version of that code system that the user was using when they selected that code. And then there's a second coding in there, which is an ICD-10 code. And perhaps, for example, that's a mapped code that's been mapped across after the fact. And then in addition to the codings, we can also have a text element that gives us sort of lower level of interoperability that we can use if we need to. So the three resources in FHIR that are really interesting from a terminology point of view are code system, value set, and concept map. So code system is some set of concepts with a coherent meaning. Sometimes that'll be well-known code systems like SNOMED CT or ICD-10 or LOINC or HPO or things like that. But sometimes it'll also be proprietary code systems that are specific to a given jurisdiction or even a given hospital or clinic. So it might be the codes that are assigned to different locations in a facility, for example. And each of those code systems will be identified by a URL and a version. It could also have lots of metadata, name, title, and the publisher, and the contact details for the author, and so on. And functionally, it can also include filters and properties. And these are things that we'll use when we try to draw codes out of that code system to build up a value set. And then each concept that's in the code system will specify a code. It can specify a display, it can specify a definition, and then things like designations, which are often used as synonyms. The second resource then is the value set resource. So a value set is some selection of codes drawn from one or more code systems, commonly one, but there are good use cases where you want to draw from multiple code systems as well. A set of codes which are cultivated or curated for use in a specific context. So it might be for use with a specific input field in a form, or it might be a specific field in a database that's used for validation or something like that. And we'll talk a little bit later about how we build those value sets out of code systems. And the third resource, which I'm not going to get into a lot of detail today, is the concept map. So the concept map is how we specify the relationship between codes in one value set and codes in another value set. So this can often be equivalence relationship. So we might be doing, for example, a mapping between proprietary lab codes across to LOINC, but there are also good use cases where they're not equivalence relationships. So for example, we might be mapping up very specific clinical codes up to reporting categories, or we might be mapping sort of procedure codes across to billing codes or something like that. So just a really quick update on recap, I suppose, on how FHIR works, because I'm going to reference some of these things as we go along through the presentation. Hopefully you got to see Simone's presentation earlier today about introduction to FHIR, which would have covered some of these things. So FHIR supports the scrub operation: search, create, read, update, and delete. And these are mapped through to the HTTP request verbs: get, post, put, and delete. FHIR also supports operations, and operations are particularly important for terminology. So operations can be defined either at the resource level or at the resource instance level. And we can either pass in parameters to that operation as URL parameters, or we can pass them in as a parameters resource, which goes into the request body. There's also slight variations depending on whether the operation is one that you can call over and over and expect the same results, or whether it might have some side effects or some state change. But we probably won't get into that a lot today. So the first use case I want to talk about is designing interfaces for data entry. So this is a very common use case. Sometimes that data entry will be clinicians, sometimes it will be patients, sometimes it will be administrators or other people. The first thing that you want to do if you're designing one of these interfaces is you need to settle on which code systems you're expecting to receive your coded data in from the user. Ideally, these will be standardized ones, but in a lot of cases, there are good reasons that they'll be proprietary ones. Once you've picked your code systems, you need to narrow those down to value sets. Preferably using rules, pulling the codes out of those code systems that are allowable for data entry. If your value set is small, you might be looking at something like a pick list that could be populated using expand. But more commonly, as soon as you get more than, say, 10 codes or even sort of 5 or 6 codes, you start needing to look at something like a type ahead widget just for usability reasons. And for that, you can use, for both of these use cases, you can use the expand operation. And for type ahead, you can use expand with the filter parameter. So just as a quick example of that, this is a user interface that was built, that we built in collaboration with SNOMED International, just to demonstrate how data entry can be supported for SNOMED coded data. So I'll jump across to my browser and show that live quickly. So hopefully everyone can see my browser here. So I might jump across to the allergies page here. So this allows us to do sort of type ahead style entry. So I might say, you know, this is an adverse reaction to latex. And that's appropriate because that code set, that value set that we're drawing from is a very large value set. I think it's got 100,000 elements or so. If, on the other hand, this value set for this next element for the criticality only has 3 elements, so it's appropriate in that case to use radio buttons. So that's just using an expand, a FHIR expand operation with no filter. We can also support multiple coded elements. So we could say that it manifests as a rash. There's also a cough, and maybe there's anaphylaxis or something like that. And then we could also use a pick list, so a drop-down style thing here. So this value set only has 4 values, so we can support just 4 values there. And all of these are using the expand operation. And the type ahead ones are using filter, and the other ones are just using straight expand with some of the other parameters that I'll get into. So to go back to our slide and to dive into this a little bit further, that first operation is the expand operation. And this is the main way that we search for a code in FHIR. So the basic purpose of expand is to retrieve the expansion of a value set, because value sets are often, in fact, usually defined by rules. And in order to actually select the value, we need to process those rules to work out which codes are actually in the value set. And when we do that, the value set, the operation will come back with another value set, which will look a lot like the same value set, but it'll also have an expansion element in it. And this will have the actual codes that match the expand operation invocation, the request. So some of the parameters we can pass to expand, we can tell it which value set we're interested in, either by specifying a URL of the value set. So value sets are identified by URLs, or we can pass in a context. So this is the FHIR element or the profile element that we're interested in populating. And if we do this, then the server will run off and look at the structure definition for that resource or for that structure or for that profile and pull out the value set binding. Or we can pass in the value set as part of our request. So if we're passing in an expand as a post request, then we can send through the value set that we're interested in. And that's really powerful because it allows us to do dynamic value set expansion. So we can build up the value set as the user's going through the interface and customize the value set so that the responses they get back reflect perhaps values that they've entered earlier in the form, or perhaps even reflect things that we know about that patient or that user. The filter parameter is a text parameter that we can pass through. So this is really useful when we're doing type ahead. So we can pass through whatever the user's typed so far, and the server can use that to tailor the codes that come back to be codes that match that filter. And that they might match it using the display text. They might use things like the synonyms that the code system has specified, or even other heuristics if the server wishes to. The count and offset parameters are how we do paging with the expand operation. So we can say we're just interested in a few codes to come back, or we can say we're interested in the second page by saying, yeah, skip the first 10 results. I want the second 10 results. There are a bunch of other parameters we can pass through as well. So include designations, include definition. Those allow us to change the shape of the value set that comes back to have more or less detail in certain parts. We can also, for example, pass through the display language. So if we're doing an internationalized UI, then we can say we want the Spanish language result to come back, and that will look at the designations that are specified on the code system, or perhaps any code system supplements, which I'll get to later. And it'll use those to change the display term that comes back with the code. So I'll go through a couple of examples of this. This first example, so I've got the actual HTTP requests, and I will make these slides available later. All of these links, we'll send these requests through to a testbed terminology server that you can try these out on. So this first one we'll send through the expand operation. We'll pass the URL parameter in to tell it what value set we're interested in. And we're going to tell it we want to expand the administrative gender value set from the FHIR spec. We tell it we want FHIR JSON back, and it comes back with a value set. And importantly, that has a contain section, which has all of the codes that the server has sent back that match that value set. Now, the order that those codes come back in will vary depending on the terminology server that you're using. In this case, we didn't send through any parameters, so it's probably just up to the server to send those back in whichever order it likes. And usually a server will try to respect the order that they were probably defined in the value set if there was a sort of predictable order specified in that value set definition. So this second example, we're going to use a filter. So what I'm going to do here is I'll pass through the URL, and this URL loink.org/vs, this is actually what we call an implicit value set. So an implicit value set is one that exists just by virtue of the URL pattern. So in this case, the server may not have an explicit value set resource, but it's got the loink code system, and the loink code system specifies this as the value set URL for that code system. So this value set is actually all codes in loink. And we're going to pass through a filter, which is urinalysis, and we're just going to ask for the first 3 results. So the server will come back, it'll give us a value set as a result. It actually tells us in this expansion element that there were 52 elements that the server decided matched that filter. And it's just showing us the first 3 of those. And it shows those down in the contained section here of the expansion. You'll notice that each time it puts a code in, it gives us the system and the code and the display. That's because the value set can have codes from multiple code systems, so it doesn't need to tell us which system. Here's one more example of expand. In this case, I'm going to use that context parameter. So I'll ask for the expansion of the medication where the context is the medication.status field. And then when we run that, the server comes back and it says, well, here's the value set that I've expanded. It'll tell us that it was actually this value set up here. So that's what the server resolved that context to. And it comes back with the codes that were in that value set. So the next use case I'm going to talk about is the use case where we're validating some coded data that we're receiving. So the main operation that we're really interested in here is validate code. So once again, when we come across this scenario, we're going to choose our code systems and value sets. And then we can use validate code to try and check whether the codes are valid in the context in which we're using them. And we can also use it to check whether the display text is correct as well. We may also want to do some other things like use the translate operation to use some of our maps to map foreign data across, or perhaps even aggregate some of these things up as well. But I'm just going to talk about the validate code operation for a moment. So validate code is a very simple operation. You pass it a code, you give it a value set, and the server comes back and says, yes, that's a member, or no, that's not. The extra little feature that it has is you can pass it in some display text. And if you do that, then the server can also come back and say, yep, that's the correct display, or that's an acceptable display text for this code, or no, that's not an acceptable display text for this code, which is really valuable. For example, if you're receiving data that comes from a system that allows you to change the display text of a code, which is a very dangerous thing they should never let you do, but they do. You want to be able to detect whether the display text that you're receiving does align to the code, or whether they've done something horrible like they've searched for cancer and changed the display text to be no cancer, which is a real clinical safety problem. This operation does exist on code system as well, but we'll look at the value set version. So here's an example where we're going to pass in a URL. This URL here is the implicit value set for all of the codes in SNOMED CT. In practice, because SNOMED CT is so big, this is something you don't really do in a real system, but I'll use it in this example because it's a bit simpler. And I'm going to pass in a code here. Now, because it's a value set that could potentially have multiple code systems in it, I need to tell it both the system and the code of the code that I want to validate. So I'll say, I need you to check whether this value set contains SNOMED code 383620002. And when I pass that in, the server comes back, hopefully very quickly, and says, the result is true. Yes, that code is a member of that value set. And just for your convenience, its display text is dengue fever. Another example, so in this case, we can pass in a display text. So we'll call validate code again. Again, the value set we're interested in is all of SNOMED. We'll pass in this code 136440009. And we'll pass in the display text. So the user has typed in this display text hypercholesterolemia. And when we send that to the server comes back and says, look, yeah, that code exists in the value set, but the display text you sent through is not correct. And up here, it's got the correct display text, which in the Australian version of SNOMED has AE as the correct spelling for hypercholesterolemia. I think the current best count for number of spellings of hypercholesterolemia in a collection of data is about 758 different spellings. So this is really useful for being able to detect all of those. So the third use case I'll talk about is exploring concepts. So we often want to do this where we've received a bunch of codes, or perhaps we're just interested in looking through a code system to work out how they relate. So just as an example of this one, I'll duck across to my browser again. I'll show our browser Shrimp to show how it uses some of these operations. So this is our Shrimp browser, for those who haven't seen it. It's a generalized FHIR terminology code system browser. It's most commonly used for SNOMED CT, and it allows you to sort of look at the hierarchy, find out different properties of codes. So if I search for example, suspected COVID, then I can come back, I can see all the details about that code, I can see all of its synonyms, I can see the effective time when it was added to the code system in SNOMED, whether it's primitive or not is the thing. And I can find out all of that information, and I can also get some information about the hierarchy, so where that code exists within the hierarchy, what its parents are, if it had any children, what its children are. And this is all just using the FHIR Terminology Services API, and the particular operations that this interface is using that we're going to talk about are the lookup operation and the subsumes operation. So the lookup operation is the one that gives us the details about the code. So this is allows us to pass in a code, and the server will then come back and tell us specific information about the code, what its display text is, what its properties are, does it have any designations, so synonyms usually. So here's a quick example. So in this case, I'm going to call that lookup operation. The system I'm going to pass in this time is a code system that I've made up. So this is an example of where you might have made up a proprietary code system. And I'm going to give it the code WA. So the server comes back, it says, okay, the code system you're drawing this from is the Australian Jurisdictions Code System version 001. The display text is Western Australia. It's also got this designation, which is a synonym, which is West Australia. So that's, this is a SNOMED code meaning synonym. So it'll say, this is perhaps also an acceptable term. So if the user types in this, then that's okay as well. And then it's come back with a property which says its parent is the AU state concept. So the other operation that was really evident there in Shrimp is the subsumes operation. So the subsumes operation is an operation that allows us to query hierarchy in our code system. So what, if any, subsumption relationship exists between two codes? So the way we use that, we just pass in two codes. In this case, I'm going to ask about these two SNOMED codes. So these are the SNOMED codes for, I believe, for body part and hand. I could be wrong. If you're following along at home, you're welcome to look those up. So we send through the two codes, and the server will come back and say, yes, code A subsumes code B. And the other possible answers that it could have given us, it could have, if we'd passed those in the other order, it could have come back and said code A is subsumed by code B. So the value code here could have been subsumed by. If we'd passed in the same code for both code A and code B, or if it's a code system that supports a compositional grammar where the codes are a bit different, but they mean exactly the same thing, like UCOM or SNOMED with its post-coordination grammar, then it could come back and say that those two codes are equivalent. Or if the server knows, can compute no subsumption relationship between the two codes, it could come back and say not subsumed. So those are the four possibilities: subsumes, subsumed by, equivalent, or not subsumed. So I'll dive now a little bit. So those are the main operations that I'm going to talk about. There's also the translate operation. And when I put the slides up at the end of this, there are a couple of examples of translate as well. I'm not going to get into them today. Instead, I'm going to talk about a couple of the resources in a little bit more detail. So I'll start with code systems. So one of the things with code systems is if you're using a standardized code system, the FHIR spec actually has things to say about it. So things like SNOMED CT, LOIC, ICD-10, UCOM, these code systems have specific mappings into FHIR. So they have a number of parts of the code system that are locked down. So they typically have the URL is fixed. So you can go to the FHIR spec page and work out what the URL is for that code system. There's a versioning syntax that they've probably specified. They've locked down, or they've specified what some of the filters and properties are that will be available on that code system. And then they also introduce these implicit value sets and implicit concept maps. And what these basically mean is that if you've got these code systems in your terminology server, then these other value sets and in some cases concept maps will also be available without you having to create them. So I'll go through it very quickly what some of those are. So I'll quickly go over those for SNOMED CT and LOIC. If you're interested in more details about SNOMED CT, there's a talk, I think, on Wednesday or Thursday by Peter Williams about SNOMED. I'd encourage you to go along to that. So SNOMED has this URL pattern and then these extra bits on the end that you can use when you're constructing a version for the SNOMED edition that you're using. It has a whole bunch of properties. So in fact, all of the relationships that are defined in SNOMED CT, which is a lot of different relationships, they're all available as properties. And then it's got things like normal form and the module ID and whether it's sufficiently defined and so on, things like that. And all of these things are available as filters as well. And SNOMED CT also specifies some filters for subsumption so that when you're building a value set, you can say all descendants of a certain code. There are filters for ref sets. So you can say all codes that are in a certain ref set. And then for ECL expression. So ECL is the expression constraint language, which is a very powerful query language for searching for SNOMED codes based on the different relationships in the SNOMED model. So SNOMED defines a bunch of types of implicit value sets. So there's an implicit value set for all SNOMED codes, which is just this SNOMED.info SET5ES. There's a pattern for implicit value sets by subsumption. So if you put 5ES equals is/, and then some code, that will give you the value set of that code and all of its descendants.
Yeah, 5 minutes left, Jim.
Sure, thank you. There's a implicit value set for all of the ref sets in the particular SNOMED version you're using, all of the codes in a given ref set. And then all codes that match an ECL expression that you can pass in the URL. SNOMED also has implicit concept maps. So SNOMED has things called historical associations. So this is when they retire a code, they will often tell you which codes it has been replaced by or which codes it's equivalent to. And I think there's four of these different historical associations, and you can query those as a concept map, and so you can translate a retired code across to the updated code. In LOIC, so LOIC specifies its URL as well. It also allows you to put a version in there. The actual version syntax for LOIC is just x.y, so 2.67, for example. There are properties for all of the LOIC definitional axes, so the 6 major axes in the LOIC hierarchy, as well as things like status, so whether it's a deprecated code or not. And then there are filters, oh, sorry, I should have updated that. There are filters by hierarchy as well that you can use for LOIC. It has implicit value sets for all of the codes in LOIC. It has other implicit value sets by multi-actual hierarchy. So for example, this is the this is the value set representing glucose as a loic part and all terms that descend from glucose in the multi-axial hierarchy. And then by answer list as well. So if you put the answer list code at the end of the value set, the members of that value set will be all of the answers in that answer list. So if you're authoring terminology resources, I'll just get to this fairly quickly. You can create your own terminology resources. They're just FHIR resources, so you can do them. You can write them yourself as JSON or XML. When you do that, there's certain patterns that you need to follow. So the code system resource, it's got a whole bunch of metadata properties. The really important ones are URL and version, because that's how your code system is going to be identified from elsewhere in FHIR, particularly from within value sets. Then there's sort of metadata like name, title, identifier, what the publication status is. And then there's a few metadata elements that tell you a little bit about how the code system will behave. So are the codes case sensitive? Is there a compositional grammar associated with the code system? Supplements, which I'll get to in a moment. And what are the properties and filters that it supports? So those properties and filters, you can specify the type. If they're filters, you can specify which filter operators you're supporting. And those become really useful when we start to assemble value sets. Oh, we can also put codes in a hierarchy inside the code system. So we can use nesting to represent that hierarchy. Or if we're trying to represent a poly hierarchy where a code can have more than one parent, then we can use the parent or child properties. Most terminology servers support that as well. One of the very new things in FHIR is the idea of code system supplements. So code system supplements allow you to override display terms in a code system. They're a way of changing a code system that's published elsewhere that you need to use. You can add synonyms to terms, you can add properties to terms. One thing you can't do in a code system supplement is add new codes to that code system. The way you do this is you set the code system.content element to supplement in your code system resource, and then you set the code system supplements field to point to the canonical, i.e. so that's the URL and optionally a version of the code system that you're supplementing, that you're adding information to. And the really, really most powerful use case for this is language translation. So if you're working in a different jurisdiction, you need to change the language that the display terms to be in your local language, then you can use supplements to do that. So just very quickly as I finish up on the value set resource, the value set resource is how you select codes. The way you do that is using include and exclude clauses. There are 4 types of these clauses. So you can either specify a whole code system, a list of codes from that code system, some filter where the codes have to conform to some filter. You can import or include or exclude other value sets, and then you can combine those. So if you combine those within a single include element, they'll be ANDed together. So it's the intersection of things that satisfy all of those. And if you put them in separate include elements, then they'll be ORed together. So you get the union of them. And then obviously there's the expansion element in the value set as well.
And Jim, I do apologize. We are at time. So
That's
thank you very much. Thank you very much for your presentation. And thank you all for attending. If there are any unanswered questions in the Q&A and Whova, please note that they will be persistent. So Jim and the moderator will be looking at those and we'll make sure you get those answered. And please do check your agenda to follow on to Wayne Kubik's closing remarks for the first day. So thank you so much, Jim.
Cool. Thank you very much.
All right.